we have here, guys, is a particle is projected vertically upwards with velocity u meters per second. Its height is h after t1 and t2 seconds respectively. Prove that t1 multiplied by t2 is 2h all over g. So what I recommend here is we throw it up, speed u, it comes up, then comes back down again, and at a certain height, it's at a certain height at t1 and t2 respectively. Now, what we're going to say here is that it's u vast, UVAST, T is T, S is H, A acceleration is going against you, so it's minus gravity, minus G. V, we haven't got a clue. U, we'll call it U. Now, we have a choice, okay? V equals U plus AT. Now, why would I rule out V right away? What would be my problem with V? Which V are we talking about? Are we talking about the V on the way up or the V on the way down? Which one is it? Now, as it turns out, it's symmetrical, as in it was going 5 meters per second on the way up. It's actually going 5 meters per second on the way down. But it's not a great choice given that there's two values of V. So what we can then show is S equals ut plus a half AT squared. Now look at this one. We get H is what we wanted. We get ut. And then we're going to get minus a half gt squared. Now, looking at this, like what is this? Like it's a quadratic equation, alright, but it has so many different variables in it. Okay, so let's get rid of that half for a start. And what we do is this: 2h equals 2ut minus a half gt squared. Get rid of the halves. Bring the gt squared over the other side. Minus 2ut. And then plus 2h. Now that's a quadratic equation. Okay, now in this quadratic equation, we still haven't got rid of our u value. Okay, so we haven't got rid of that u value yet. So, let's see. Okay. So, they did a trick that's no longer on your course. It's called the product of the roots. Okay, it's no longer on the leaving cert course, so you guys won't know this anymore. So what we're going to have to do is we're going to have to bash out the way you guys would do it. I'm going to go for the minus b formula and hope it works out. Okay, so minus b formula, a equals g, b equals minus 2u, and then what does c equal? C equals 2h. Okay, so we're going to do the minus b formula here. Minus b plus or minus the product of b squared minus 4ac all over 2a. Okay, so what we have here, guys, is this. We're going to have 2u plus or minus the square root of, now what's b squared? That's 2h, by the way. B squared anyway? 4u squared. Okay. And 4u squared. Then what's the other one then? 4u squared minus 4ac minus 4 times g times h minus 4gh all over 2g. Now, looking at this, still hasn't got me anywhere, but what I'm most definitely going to do, I know it works out, because it tells me it works out. So what I'm going to do is I'm just going to come up with my two different answers, T1 and T2. T1, let T1 be the plus answer. Yeah?
4g 2h, isn't it? 4g by 2h. You need to divide it.
Oh, sorry. You're right. It's 4g by 2h, which makes that 8gh. What are you asking me?
Can you divide it by 2 so you get u plus minus g squared minus 4gh?
It doesn't work that way in a square root because the square root is within a function, so you don't do that just yet. You won't actually have to. Okay. Now t1 is u plus the square root of 4u squared minus 8gh all over 2. T2 is 2u minus the square root of 4u squared minus 8gh all over 2. Now, here comes the horrible part. Everybody ready for the bad part? I got to multiply the two of these by each other. Okay? Now, okay, what used to be a 3-line question in your old Leaving Cert now becomes a much larger version. Okay? So lads, what you can do here is this, okay?
It's over 2g. Yeah.
Sorry?
It's not over 2g.
2g, yeah, it is over 2g, sorry. Now guys, here's what's going to happen next, okay? Going to multiply one of them by the other one. So, what I'm going to do, to make things a lot easier, I'm going to call this root x. Does everybody understand that x is going to be 4u squared minus 8gh. Is everybody happy with that? I just want to shorten the whole thing down. It looks absolutely horrible. Like so. What I'm going to do is this. It's going to be 2u plus root x all over 2g. And then it's going to be 2u minus root x all over 2g. Now look at what happens with the effect of this. 2g by 2g, 4g squared. 2u by 2u, 4u squared. Then it's going to be minus 2u root x plus 2u root x. And then it's going to be root x by minus root x. Just minus x. Because root x by root x is minus x. Now guys, look at this. They cancel. And what is x? X is minus bracket 4u squared minus 8gh. Now look what happens here. The 4u squareds cancel. Minus minus 8gh is plus 8gh all over 4g squared. And then the 4 cancels with that. Comes 2h all over g. Done. It's very complicated, okay? Now let me show you the really easy way that's no longer on your course, okay?
How we do that way?
You can, yeah, it's still viable. I don't think they're going to go there. Like this question again, I don't think we'll turn up again, but just in case.
Why did they take it off the Leaving Cert course?
Okay. So, what I'm going to show you next is a trick to do the same equation again. Now, can somebody give me the quadratic I had before I began?
gt squared minus 2.
Okay. gt squared minus 2ut
Plus 2h.
plus 2h equals 0. Now guys, all quadratic equations, for example, x equals 2, x equals 3. This all stems from x minus 2 equals 0, x minus 3 equals 0. You then multiply this out into x minus 2, x minus 3 equals 0. And then all of a sudden your answer will be, when you multiply this out, it's x squared minus 5x plus 6 equals 0. Is that alright? Now, there's a generic rule for this. The generic rule is this. X squared minus brackets sum of your roots. Now what does sum of roots mean? Your roots are 2 and 3. When you add 2 and 3 together, you get 5. And then this part here is called plus product of your roots. What's the product of 2 multiplied by 3? 6. So an example, if I had an equation like this, x equals minus 1, x equals 7, I could make that equation really fast by doing it like this. X squared minus, what's the sum of the roots? 6. X. What's the product of the roots? These answer results from this equation. Okay? Now please notice one thing about this. The one thing I really want you to notice is that there is no number in front of the x squared. The only number that's in front of it is technically the number 1. I am now going to adjust my equation here so that it meets the same criteria. So to meet the same criteria, what I say is this. To meet the same criteria, what we're going to say is that t squared minus 2ut over g plus 2h all over g. T squared minus sum of roots. Now what do I mean by sum of roots? Sum of roots is t1 plus t2, or your two x values added together, times t plus product of roots. Now what's the product of the roots, lads? T1 multiplied by T2. And what is the product here? Hence T1 by T2 is 2H all over G. There's no doubt which is the faster way. But what I'm trying to say is that in a test, if you forget this fancy trick, because it's no longer on your course, you can always go through the minus b formula and work it out. But ideally you'd want to be remembering that.
Or could you just do that to get T1?
Remember I said t squared minus sum of roots plus product of roots.
Yeah.
Product of roots, the answer is, in any quadratic equation, you'll get two t answers. One of them's t1, the other one's t2. When you multiply these two answers by each other, they always give you the third variable that hasn't got the x, or the third number that hasn't got the x in it. Okay? Always happens that way. If you look over the two examples I gave you before that, if I said, look, x equals 5, x equals 6, my equation is going to be x squared minus, add them together, 11x. Multiply them together, 30. And that's the equation where they come from. But the whole point is that the two x values, x1 multiplied by x2 is 30. So whatever's left over is the product. Okay, move on, next question. So it's done two different ways, okay? Now, okay guys, so look at this one here. Car has to travel a distance s on a straight road. Car has a maximum acceleration a and maximum deceleration b. It starts and ends at rest. Show that if there is a speed limit of phi meters per second, the time taken to complete the journey is given by phi over 2a plus phi over 2b plus s over v. Time taken. Okay, time taken. So, velocity time. Why am I going for the velocity time diagram? Can you tell me? Why did I even think about doing that?
There's only one car.
One object, three distinct intervals. In acceleration interval, constant speed interval, and finally deceleration interval. And how many different times is there? T1, T2, T3. If I find out what all of them are combined, then I figure out the full thing. Now, it wants S in my answer. See the way it wants S in my answer. Okay? S is the entire distance. So, S equals my triangle plus my rectangle plus my other triangle. Okay? Now, therefore it's phi t1, phi t2, phi t3. S therefore equals a half phi t1 plus a half, sorry, not half, plus phi t2, and finally a half phi t3. Is everybody happy with that formula? Just the area. The area of all three objects equals the total distance S. Now, we're looking at this and we're going, well, I have S, I have V, but have absolutely nothing to do with A and B. A and B are the true problems here. Like, I haven't got them involved yet. So, we gotta go back and figure out what A is. Now, can anybody tell me what acceleration is again in the velocity time diagram? A is equal to tan x, and tan x equals? Okay. Therefore, T1 equals phi over A. Okay, so T1 equals phi over A. Likewise, B equals tan y, which is going to be phi over T3. Therefore, T3 equals phi over B. Now, okay. So it hasn't really got me anywhere just yet. Now, what I could really do with known is what I need to find out. What is the total time taken? The total time taken is T1 plus T2 plus T3. T squared, okay, distance over time taken, grand. Okay, so, distance over time.
So you'll sub in the values for T1 and T3 and then it'll start working out.
Yeah, I'm looking at that. I'm still going to be left with T2. So I'm actually ahead of myself here. So, yeah. So that's inspiration. Okay guys, what would be a great thing to know, would be the middle distance. What is the middle distance? What is this value? Let's just call it x for the time being. Okay, let's alter phi T2, because I don't know what T2 is and I have no way of locking down on T2. So having T2 in there is not really helping me at this point in time. So what I'm going to ask, what we do here is that we just eliminate that off to being x for the time being. Okay? Now, and I'll tell you what I'm going to do with that in a second. I want to find out what x is. Okay? Now, as discussed, I'm going to sub in with T1 and T2 and T3 values. So I'm going to get T1 and T3. So I'm going to rub out T1. I'm going to rub out T3. And I'm going to put in my two values, V over A. And then it's going to be V over B. Now, I'm going to bring these over the other side, the whole thing, and I'm going to get x is going to equal s minus a half, what's it going to be, phi squared over 2a, and that's going to be minus phi squared over 2b. Would everybody agree that's the distance of the, that's technically the area of the rectangle, the middle distance. Everybody happy with that? Now, once you've done that, what's going to happen next is that you're going to have to find out what is T2. Now, as discussed earlier, T2, or this rectangle we got has an area. Its area is T2 multiplied by V. So, T2 ends up to be S minus phi squared over 2a minus phi squared over 2b. It's only now we can isolate T2 in terms of all the letters in this given answer. Okay? So once we do that, here's what's going to happen. We're going to get T2 ends up to be S over V, because you're dividing S by V. You're going to cancel off that V there with another V underneath. So technically it's like this. V, V, V. And then they cancel like that. And we're going to get minus V over 2A minus V over 2B. Okay, that's T2. Okay? Now, what was the whole goal of the question? T1 plus T2 plus T3. Okay? That's the whole goal of the question. So, therefore, the goal of the question becomes this. I have all the information I need. I'm going to rub out all the other pieces I don't need. There it is. I have everything that I need left on the board. It's all there. I have T1, which is P over A. T2, which is this massive pile here, which is S over V minus V over 2A minus V over 2B. And then finally I have T3, which is V over B. Now, what I'm going to do next is I'm going to interact the two of these objects. I'm going to say that's 2V over 2A, that's 2V over 2B. And why would I do that? Because 2V minus V, V over 2A, plus V over 2B, plus S over V. Okay? So, this next question here, show that if there's no speed limit, the time is given by 2S, A plus B, all over AB. Now, suppose I was to give you a simpler question. Something similar, okay? Suppose I was to say that your acceleration is 3, your deceleration is 8, your maximum velocity is capped off at, 24. We'll cap off the maximum velocity, okay? Now, it's not similar in some ways because you're not given a maximum velocity to cap off on, right? But in this question, eventually there is a maximum speed limit that has to be obeyed. Okay? Now, in this question, I'm going to specify that we're just going straight up and straight back down again. I'm going to specify that myself. Okay? So, if you look at this diagram here, what's going to happen is you're going to go all the way up really gradually, and then you're going to come down really sharp. Okay, so you're gonna get 24, and you're going at an acceleration of 3. Now, how long is the first time going to take?
8 seconds.
Sorry?
8 seconds.
It's going to take 8 seconds. So if I was to use V equals U plus AT, or I could use tan X equals 24 over T1, whichever one you want. So if I was to use V equals U plus AT, it'd be 0 plus 3T equals 24, T equals 8. So T1 equals 8. Opposite way around, T2 will be equal to 3. Okay? And we can figure out the times quite easily from that. Okay? Now, if I was to be more abstract about this, so what I mean by abstract is if I wasn't to use the total, it was to try and find this out as a product of total time. What is the total time here? 11, right? So total time equals 11. Okay? Now, what did I tell you before about the ratio of T1 to T2? The ratio of T1 to T2 is the ratio of deceleration to acceleration. Okay? Which is the ratio of 8 is to 3. Therefore, T1 is technically 8/11ths of the entire time, and T2 is 3/11ths of the total time. Would you agree with that? Yeah. Now, if I put this in the abstract, what we have is this. T1 is deceleration divided by deceleration plus acceleration multiplied by total time. T2 is acceleration divided by deceleration plus acceleration times t. Do you understand where I got that formula from? D is 8. 8 divided by 8 plus 3 is 11. 8 11ths. T2 is acceleration. A is 3. A plus 3, 3 11ths. So do you see that ratio? See this here? It gets really complicated, but this is basically what you're doing. So we've done a simpler version of this question. Now I'm going to do the hard version. Okay, now look at this. Okay, so what we're going to do is, this one I don't know the speed limit. I don't know anything about the acceleration, deceleration. Okay, and I don't know anything about this here and this here. Okay, I'm just going to leave that formula there I came up with. Okay, now this formula, what we're showing is that the acceleration is A, the deceleration is B. Acceleration is A, deceleration is B. Okay? Let's call the total time, what do you want to call the total time? We'll call it T. Capital T equals total time. Okay. Go and change that to capital T. Go and change that to capital T. Now, can anybody tell me what T1 is now? What's your deceleration?
B.
B. What is your acceleration? Or sorry, what's your deceleration plus your acceleration? What? B plus A or A plus B, whatever if you want. Tomato, tomato. And then capital T. What's T2? What's T2, lads?
A over A plus B.
A over B plus A, same thing as A plus B times T. That's the same thing as our 8 and 3 question we did a second ago, 3 11ths and 8 11ths. It's just dressed up in fancy letters. It's the same stuff. Now that we've done that, what you're going to look at here is show that there is no speed limit. What is the area of this what is the time of all this? Or sorry, what is the 2s? We have to introduce s into the equation. So guys, see the way we have s here? See the way s is in the answer? We need a way to get s into this. What's the way we're going to get s into this? Or given that we have a diagram,
Half base per
half base by height, a half phi by t. Now, what we could do with doing here is half base by height. Okay, so if we use phi equals u plus at, okay, bit dodgy. Now, starting off at 0, acceleration up to the maximum speed of v, correct? So phi equals 0 plus its acceleration, still a. And what's a going to be multiplied by? What is the time fraction t1? It's b plus b over a multiplied by capital T. Phi therefore is ab capital T all over b plus a. Let's call that a plus b just for the sake of it. Now, isolate t on its own. Or is it time? I still haven't put s in here yet. Yeah. Should be okay.
You need B for.
Put S in now, Patrick.
Sorry?
You put S in now, Patrick.
So B's for the.
Oh, yes. So, what I have here? No! Okay, so guys, what I have here now is I have this information that phi is ABT all over A plus B, and what I was looking at all along is exactly what I need. And what I need is S, phi and T in the same formula, as agreed, and therefore it's going to be S equals a half ABT all over a plus b, all multiplied by t. Now, we're going to get t squared when we multiply the two of them by each other. Everything else has to go over the other side. So the 2 multiplies up to give me 2s. And that's going to be ab over a plus b. Cross multiply, we get 2s into a plus b all over ab equals t squared. T therefore equals the square root of 2s into a plus b all over ab. And that's your answer for question 5. Now guys, I think that's a very difficult question. Okay?